Okay, you guys, we're going to go ahead and get started for today. If you would for me, please open up your notes packet to page 11. We're on page 11 today. So last week we started talking about graphs and looking at graphing, but we were graphing based on some data. So we had a table of values that we were either given or we created, and then we plotted those points. And once we had those points plotted, we decided if we should have connected those, put arrows or not. So we had data to start with, precise points, and then we graphed that and then made decisions about our graph from the data we were given. So if I flip back really quickly to what we looked at last time, this is the last example we did together in class on Friday. We had this scenario here. We used it to create a table. We plotted our points. Based on the information, the context of our problem, we decided not to connect our points. And then we decided to put an arrow on this end. So that's what we looked at last week. Today, we're going to continue to look at graphs, but this time we're not going to start with a set of information. We're not going to start with points. We're actually going to either create or start with the graph and then use the graph to be able to answer questions about specific points. So we're going to kind of flip it around this time. So on page 11, we have two different coordinate planes that we're going to work on. And we're going to sketch graphs on here based on a couple of videos that we're going to watch. We have two short videos that we're going to see. The first one is called Distance from the Bench. The second is called Height of Waist Off Ground. So for distance from the bench, we're going to watch someone bench press. And what we're going to track is the distance between the bar for the barbell and the bench that the person is laying on. So we're going to track that height, that distance. Okay, so let me pull up our video here. So they're labeling their y-axis. Our x-axis is already labeled for us. I'm going to pause it right here. Our x-axis is already labeled for us on our paper. They labeled their y-axis distance from the bench. That's the other variable that we're going to track. And then they chose to mark theirs count by ones every other. So I guess technically count by half a foot or 6 inches. So if you want to take a second and label your y-axis, it doesn't have to be exactly the same as theirs, but they give you an idea of what might be appropriate. And then the next thing we'll see is the video. So in the video, we'll see the person doing the bench press. There'll also be a little clock, a little timer in the corner, so that as you sketch out where that barbell is over time, its distance from the bench. So let's say it starts off maybe 1 foot from the bench, and then it does whatever it does over the course of that time. You can sort of track your time and where about you think that bar is. Does that make sense? Okay. Now your graph may be different than your neighbor's because we're all going to do some estimating on what that distance is. We have a timer that's going to count down the seconds, but we don't have any way to know for sure what the distance is. So we're going to just use our best estimation there. Okay. Here we go. So you should be plotting on your graph either a general shape or some points that you estimate we're seeing here. Okay, I'm going to pause it again, and they're going to play the video again at half speed. So if regular speed was a little fast for you, especially at the beginning, there was a lot of movement there. They're going to play it again at half speed. So as you're watching, you are either plotting some points that you think make sense for what you've got here, or sketching sort of the general shape, the general pattern of what is happening. Again, this is the same video, just at half speed. what did your graph look like? Was it a straight line? Did you have curves? We had some curves. Kind of oscillated, right? Kind of like a roller coaster a little bit. Yeah, because as he pushed the bar away from him, that distance increased. Every time he brought it back down, that distance decreased. And so we had several iterations of pushing the bar away and then bringing it back and pushing it away and bringing it back. So in just a second, we're going to see what their graph looks like. You do not need to erase your graph to make it look like theirs, okay? It's okay for yours to look a little different. We just should all have the same general shape, that sort of oscillating up and down shape. And that's what they've got too, that up and down, and then down for a little while, and then finally that one last push to put the bar back on the rack. We're going to take a look at one more. Same idea. The video is going to go in the same format. This time we're going to look at someone climb up and then go down a slide. We're going to track the height of this person's waist. So not their feet, but their waist. And so they're labeling their y-axis, height of their waist off the ground. And they've chosen to go by ones. Looks like their increments are in feet. So 1 foot, 2 foot, 3 feet. And then your x-axis, your time is already labeled for you. And we've got the same setup here. We'll see the video once at regular speed. There'll be a timer in this corner. Then we'll see it again at half speed, again with a timer in the corner. And your job is either to plot as we go along, or if you are comfortable just sketching whatever we see on your graph. But by the end of that second showing of our video, you should have a graph sketched of height of waist versus time. And then here's it again at half speed. What's the general shape of your graph this time? I saw up and then down. Okay. I was just going to ask, is it straight up and then straight down and we've got like a peak? No, we've got that sort of plateau at the top, right? He has to walk across the top. There's a peak, part where he sits at the top of the slide for a little bit. So we've got a couple flat parts in there, but we start with an incline, an increase in height, and then we end with a decrease in height. So let's take a look at what they got. Again, you don't need to change your graph to match their specific height. We're estimating. Okay, so there's that increase as he climbs up. There's a plateau as he walks, then a decrease, and then another plateau as he sits down and remains sitting. And then finally, that decrease as he goes down the slide. And then they were super specific. They even did that little increase again as he stood up. But you should have had increase as he walked up, a plateau as we walked across the top of the structure. And then there's where he sat down And then that's where he was sitting at the top of the slide. And then there's where he went down the slide. Okay. So what we're going to do today is we're going to start with a graph like this and then pick out some of these key features or points on the graph to be able to answer questions. Okay, and that's where we're going to go with this. So if you would for me, please turn to page 12, turn the page to the next page in your packet. So we'll be on page 12, and we're going to take a look at another graph example. So as I move to page 12, I'm starting this time with a graph. Instead of a table of values, I'm starting with a graph. And it says that the altitude of a tree affects the rate at which the tree grows. So that's what I'm seeing here in this graph. So I've got this sort of curve here. My x-axis is labeled as altitude in kilometers above sea level. My y-axis is labeled as tree growth rate in centimeters per year, okay? So my first question, I picked a point from the graph and I want to know what does it represent in the context of the problem. Remember, our points are always given as x comma y. My x is an altitude. And actually, let's go ahead and find this point on the graph. So 3 comma 2.2 would be right there. So we're looking at an altitude of 3 kilometers above sea level. So 3 kilometers above sea level. When our altitude is 3 kilometers above sea level, we can estimate the growth rate for trees at that altitude. So I'm going to go ahead and throw an at right in front there. At 3 kilometers above sea level, trees grow at a rate of 2.2, right? 2.2 centimeters per year. That's what that ordered pair represents in the context of my problem. At 3 kilometers above sea level, trees grow at a rate of 2.2 centimeters per year. Questions for me on that first one? Okay, let's take a look at number 2. How fast does the tree grow at 9 kilometers above sea level? So this is an altitude, this is an x value. So when my x value is 9, I want to follow that up to the graph. Like we're right about there. When my x value is 9, my y value is 2.5. So I knew the x, I was asking for the y. My y value, remember, is a growth rate. So how fast does the tree grow at 9 kilometers above sea level? It grows at a rate of 2.5 centimeters per year. So I had one piece of information, I used it to find the other piece of information. Number 3 is asking us about the y-intercept. We talked about x and y-intercepts last week. So for a y-intercept, we know that's where our graph is going to cross or touch the y-axis. So that happens right here. So our y-intercept would be the point 0, 1.4. And then I want to know, what does this point represent in the context of our problem? So remember that x value is an altitude and the y value is a growth rate. So here our altitude is 0. We're saying we're 0 kilometers above sea level. Another way we could say that would be to say at sea level. So at sea level, trees grow at a rate of 1.4 centimeters per year. Notice I made sure to include both of my labels in my answer. What's my altitude? We're at sea level, or you could also put 0 kilometers above sea level. That would be fine too. And then I put my growth rate. I'm growing at a rate of 1.4 centimeters per year. If I'm ever going to describe what a point means in the context of a problem, it's important that I include those labels because that's the context. Questions for me so far? Okay, we have a couple more questions we're going to answer about this particular graph. So number 4 says, when does the tree grow at a rate of 1.7 centimeters per year? So what I have is a growth rate. I have a y value. We want the x that matches it. So exactly the opposite of what we did for number 2. Okay, we have a y. We want to find the x that matches it. So 1.7 would be right here. And I'm going to follow that to any points shown on my graph. Because of the shape of my graph, I actually have more than 1 point. That would be at 1.7 centimeters per year. So I have this growth rate at 1 kilometer above sea level, and then also at 13 kilometers above sea level. Since both of these altitudes have a growth rate of 1.7, I want to make sure I list them both. So 1 kilometer and 13 kilometers above sea level. Those are the 2 altitudes where we have this specific growth rate. My final question here asks me, what's the fastest rate of growth for a tree? What key feature am I going to look for on my graph to identify that fastest growth rate? What was that? The highest point, right? Fastest growth rate means I want the biggest y value I can have. So that's going to be our highest point, our maximum. So our maximum on our graph is right there. And it asks me, what is the fastest growth rate? So that would be right here, 2.6 centimeters per year. 2.6 centimeters per year. If they had asked me at what altitude do we achieve the highest growth rate, that would have been my x value, which would have been 7. Questions for me on page 12? Anything we looked at on page 12? Okay, so for the rest of class today, I have an assignment for you on Delta Math where you're going to practice this same thing. You're going to get a graph and you're going to answer some questions about it. What does this point mean in the context of the problem? Or if we think back to our graph stories, what's happening here where the graph is flat, right? We're not moving. Or describe a point where our height is increasing. Describe an interval where our height is increasing or decreasing, something like that. So you'll have 4 questions on your Delta Math assignment. 4 right is 100%. If you miss one, it's set up to just give you another problem. Okay, I know for Khan Academy, if you miss one, you have to repeat the whole assignment. For Delta, it's set up so you just get a new question until you get your 4 right. Does that make sense? Okay, so that I want you to do right now. You can use your own device or one of my Chromebooks if you would prefer. And your Delta Math assignment is due by the end of the class period. For homework, I would like you to complete page 13. So page 13 is another graph. I'm asking you questions about it just like we did together on page 12. Okay, so Delta Math assignment due by the end of the class period, page 13 for homework.